Take a moment to read the question. The first term of a series is 1 and every even term is thrice the term preceding it. Every odd term is 7 times the term preceding it, and we have to find out the sum of the first 100 terms of this series. How do we do this question? Well, let us begin by writing the terms of the series. So the first term is 1, the second term would be thrice that, and the third term would be 7 times the previous term. The fourth term would be 3 times the previous term. So we have this pattern now, and we can just write down a few more terms. Now over here we can see that all the terms are in the form of a power of 3 multiplied with some power of 7. So we can write down the terms in this form. So if we look closely, we can observe that there is a certain pattern in the terms. If we had to write down the 101st term, we would find that it is 3 to the power 50 times 7 to the power 50, which means the term before that, the 100th term, would be 3 to the power 50 times 7 to the power 49. Now if we separate the terms into even positioned and odd positioned terms, we will find that all the terms in the odd position would be given by this series. Let us call this series as S0. Now we can see that this is a geometric progression with the first term as 1 and the common ratio as 21. Similarly, the even position terms can be written down, and this is also a GP with the first term as 3 and the common ratio as 21. Let us call this SE. So we have SO given by this expression. Over here we have used the formula for the sum of a geometric progression up to n terms. So A stands for the first term, and R is the common ratio, and n is the number of terms that we are adding. So this can be now written down in this way: 21 to the power 50 minus 1 over 20. Similarly, SE can be found, and that simplifies to the expression shown. So the total sum would be SO plus SE, and that is equal to this expression, which simplifies to 21 to the power 50 minus 1 divided by 5. So the correct answer is option A.